Take a quick look at the everyday items around you right now. Maybe you've got a glass of water sitting on your desk, or you're sitting near an open window. Have you ever actually stopped to wonder what a refreshing glass of lemonade, the vast salty ocean, and the very air filling your lungs right now all have in common? It kind of sounds like a trick question, right? Because physically they seem worlds apart. But if we put on our analytical hats and look just a little bit closer, we uncover this totally fascinating, unseen chemistry connecting every single one of them. So today, we're going to break down that hidden chemical architecture. Okay, let's dive right into this. Welcome to this explainer, where we are going to master the fundamental building blocks of mixtures. Our main focus today is all about the analysis, breaking things down to understand how they work. By the time we finish, you are going to have a completely new analytical lens for viewing the world around you. We're decoding the secret lives of solutes, solvents, and solutions. So here's our quick roadmap for today. Number 1, analyzing the building blocks. 2, how a solution forms. 3, everyday chemistry in action. And 4, beyond just liquids.
Let's jump right into part 1, analyzing the building blocks, where we identify the core parts of a mixture.
Right. So before we can analyze the complex mixtures in our environment, we really need to nail down our core vocabulary. First up is the solute. The solute is simply the substance that gets dissolved. It's the material that's being broken down and distributed. Now here's a fantastic mental shortcut for your analysis. The solute is almost always the substance present in the smaller amount. And while we, usually picture a solid powder like salt or sugar, a solute can actually be a solid, a liquid, or even a gas. On the flip side of that relationship, we have the solvent. The solvent is the substance that actually does the dissolving. It's doing all the heavy lifting in this chemical interaction. So, if the solute is the smaller amount, the solvent is usually present in the larger amount. This gives you a really quick, reliable heuristic. Whenever you're trying to break down and analyze any mixture, just ask yourself, which component has the greater volume? Boom, that is almost certainly your solvent. So, the crucial point for our analysis is this simple juxtaposition. On one side, you have the solute, what gets dissolved, the smaller portion. On the other side, the solvent, the dissolving agent, the larger portion. Keeping this core contrast in your head is literally the master key to analyzing any mixture you encounter out in the wild. When you combine those two parts, you get our core equation. Solute plus solvent equals solution. It's a remarkably simple, repeatable equation that you can apply to almost anything. Just think of it like the ultimate recipe. You take the thing being dissolved, you add it to the thing doing the dissolving, and the resulting mixture, that's your solution. Moving on to part 2. How a solution forms, let's look at the actual mechanics of mixing. Now that we've got our static definitions locked in, we need to transition to seeing how these things interact dynamically in the real world to create that final equation. The mechanics of mixing happen in 3 very distinct steps. Step 1, you add the solute into the solvent. Step 2, you agitate the mixture. So you stir or mix it. And then step 3 is where the magic happens. The solute spreads evenly throughout the solvent. Now that word evenly is absolutely critical here. For a true solution to form, the particles of the solute have to distribute themselves perfectly uniformly. And this brilliantly illustrates exactly what that process looks like in a classic beaker demonstration. Just look at the progression here. We start with our solid salt, that's our solute. We drop it into the water, our solvent. After a good stir, what do we have? Salt water. Notice how the final result looks exactly like plain water. You can't see the individual salt grains anymore, right? The solute has spread evenly to form a totally cohesive, unified solution. Which leads us to the official definition of our final product. A solution is a uniform or homogeneous mixture formed when a solute is dissolved in a solvent. And because it's perfectly uniform throughout, a true solution has some seriously amazing properties. The solute won't settle at the bottom over time, no matter how long you leave it sitting there. And pretty incredibly, you can't separate a true solution just by pouring it through a standard filter. The solute particles are simply way too small and too evenly integrated for that to work. Okay, part 3, everyday chemistry in action. Let's analyze our drinks. Let's shift our perspective back to the macro level and apply this new analytical framework to the drinks that might literally be sitting right next to you. Let's walk through this to train your brain to spot these components instantly. Take salt water. The solute is the solid salt. The solvent is the liquid water, resulting in liquid salt water. Super simple. Sugar water works exactly the same way. But look at lemonade. This is where our analysis gets really fun. Lemonade actually has multiple solutes. You've got solid sugar and you have liquid lemon juice.
Both of those are solutes getting dissolved into the much larger volume of water, which is our solvent, and the result? That delicious liquid solution.
Now, you probably noticed a reoccurring theme just then: water. There's a massive reason for that. Water is commonly known as the universal solvent because it can dissolve so many different substances. This is an incredibly important fact to keep in mind when analyzing mixtures, because the solvent is actually what dictates the physical state of the overall solution. Since water is a liquid, the salt water, sugar water, and lemonade all end up as liquid solutions, even if they started out with solid solutes.
Finally, part 4. Beyond just liquids, let's talk about changing states of matter.
But hey, what happens when the solvent isn't water? Actually, scratch that. What happens when the solvent isn't even a liquid? It is time to challenge our fundamental assumptions about what a mixture can actually be. Here is your wake-up call to shatter those assumptions. Not all solutions are liquid. It's so easy to picture a beaker of water or a glass of lemonade, for sure, but chemistry is absolutely not confined to a cup.
Literally every invisible breath you take is actually an encounter with a chemical solution. Let's analyze the air we breathe. It's a gaseous solution. Remember our mental heuristic from earlier? The solvent is the larger amount? Well, in our atmosphere, nitrogen gas makes up the vast majority of the air. Therefore, nitrogen is the solvent. The oxygen we need to live, the carbon dioxide we exhale, those are present in much smaller amounts, so they are the solutes. These gases mix perfectly uniformly to form the air around us. Kind of blows your mind, right? And we can push our analytical understanding even further into solid objects. Let's look at brass. Think of a brass instrument, or even just the keys to your house. Brass is actually a solid solution of metals. The metals copper and zinc are melted down and mixed together. When they cool, they don't separate. They form a perfectly uniform solid mixture. So the exact same fundamental rules of solutes and solvents apply just as perfectly to hard metals as they do to sugar and water.
When we put all of these pieces together, a pretty grand perspective emerges. From a glass of liquid lemonade to the gaseous air filling the room you're in, all the way to the solid brass keys in your pocket, the underlying mechanism is identical. Solute plus solvent equals solution. By analyzing the world and breaking it down into what gets dissolved and what does the dissolving, we reveal this incredible hidden order and uniformity in the materials all around us. So, I want to leave you with this one thought. Look around you right now. Armed with this new analytical framework, you aren't just looking at plain objects or empty space anymore. You are looking at a highly complex web of chemical mixtures. So what else in your immediate environment is a hidden solution just waiting to be analyzed and broken down into its parts? Keep asking yourself that question, keep looking for those components, and I guarantee the world is never going to look the same to you again. Thanks for joining me on this explainer, and keep exploring